Hi folks. Today we're going to be learning about writing and graphing inequalities. These are just kind of the basics about inequalities before we start learning how to solve inequalities in future sections. So just a couple of important definitions first. An inequality is any mathematical sentence that compares expressions using one of these four symbols. And if you're not sure what those symbols mean, I've got a list down here for you. Less than or equal to, greater than, or greater than or equal to. Now, although that's what we typically say in math class, there are other ways to express these relationships in other words. For instance, if you ask your mom for cookies for before dinner, she might say you can have no more than 4 cookies before dinner. And so in that case, the number of cookies you're allowed to have, C, is less than or equal to 4. So we don't always say less than or equal to. Sometimes, especially in everyday speech, we'll say you can have no more than something, or is at most is another way to express this. So let's also look. So solution of an inequality. What's a solution of an inequality? That's any value that makes the inequality true. There can be more than one value that makes the inequality true. So we don't usually just talk about solutions, we talk about solution sets. We have a whole variety of numbers that can make an inequality true. And then the graph of an inequality shows the solution set on a number line, and we'll look at that in a couple examples. But first, let's learn how to, or look at how to take words and write them as an inequality. A number W minus 3.5 is less than or equal to negative 2. So a number W minus 3.5 is less than or equal to negative 2. This isn't the only way to put this inequality into words. We could have said the difference between a number W and 3.5 is no more than negative 2. So we can mix up the words that we use for the greater than and less than type of symbols. And we can also express things like subtraction in different ways. So just be aware of that as you're approaching these problems, but just kind of systematically going through examples and finding what operations we're using with what numbers. The next skill you need to be able to do is to be able to check solutions. For instance, is negative 4 a solution of these inequalities? And to check a solution, all you need to do is plug the value in for the variable. So we're going to plug negative 4 into here, and this is an addition problem, so it's negative 4 plus 8 is less than negative 3. Well, negative 4 plus 8 is positive 4, and so we end up with the sentence 4 is less than negative 3. Once you have a directly comparable situation like this, 4 is less than negative 3, then you ask yourself, is this sentence true? This sentence is not true. 4 is not less than negative 3. So we'll put a line through that because it's not true. And because it's not true, then we know that negative 4 is not a solution. Is not a solution for this inequality. Not a solution. So what does it look like if a value is a solution of an inequality? We'll do the same thing. We'll take that negative 4 value and plug it in here. Now, because there's no operation sign between the 4.5 and the x, we know that this is a multiplication problem. So we've got negative 4.5 times negative 4 is greater than negative 21. And if we do the multiplication, we remember a negative times a negative is a positive. So we get 18 is greater than negative 21. This is a true statement. And because it's a true statement, that means that negative 4 is a solution to this inequality. We're not learning how to actually solve inequalities yet. We're going to do that in a future lesson. But for right now, we're just learning to check is a particular number a solution? Let's look at how to graph inequalities now, how we put things like this on a number line. Graphing inequalities. To graph an inequality, you need to get to the most simplified version of the inequality, where you have the variable is compared to a constant. And because y is less than or equal to -3, with less than or equal to, you color in the circle. You color in the circle because -3 is a solution for this inequality. -3 is less than or equal to -3. That's a true statement. 3 is included in the solution set. So we color in a dot at the value 3. And then because y is less than -3, we color, kind of shade in this part of the arrow and shade in the arrowhead as well, so that we know all the values down here, all the way up to and including the number -3, are solutions for this inequality. Now, had this been a different inequality, had it been written like this instead, y is less than -3, then what we would have had to have done here is have an open circle, because -3 is not less than -3. This is not a true statement. And so in this case, we don't want to include -3 in the inequality. But of course, this is not what the question asked for, so I don't want to confuse anyone by having that in there. So we'll just go back to the colored in dot. How about going the other direction? How do we look at a graph and make sense of it and write an inequality out of it? So for instance, in this real world example, we've got a height restriction in inches for a roller coaster. And here I can see that the number 48 is colored in with a circle. So my 48 is the value that I'm comparing to h, the height restriction. And notice that all of these values that are bigger than 48 are colored in. So h is greater than or equal to, because this is a solid circle, h is greater than or equal to 48. So 48 inches or taller to ride on this roller coaster. So let's look at a couple of things that make graphing these inequalities a little bit easier. Remember that the symbol, the greater than or less than symbol, always opens towards the larger quantity. In elementary school, perhaps you learned that the alligator is always hungry, wants to eat the bigger meal, always goes for the bigger number. -3 is at the big end of our solution here, because the alligator is eating the larger number. Couple ways to test that. One way is to just choose a number on the number line, like -6. Plug it into your value, plug it into the inequality, like this, and see if it's true. If it's true, like -6 is less than or equal to -3, then you're sure that your arrow should be highlighted in this direction. The other thing you can do, as long as you always write the variable on the left side of the inequality, the less than or greater than sign points in the direction that you want to shade the arrow. So because this is a less than sign, it does look like this arrow on the left-hand side of the number line. So that's another way that some students remember that, hey, we need to color in the left side of this arrow. Another thing I'd like to point out, there are two ways you can write inequalities. They're both equally valid. They are both equally true. X is greater than -2, and -2 is less than x. However, students tend to make mistakes in interpreting the inequality when they don't write the x first. So this is the preferred method for most students. If I wrote this the other way, if I said -3 is greater than or equal to y, it's harder to see which way to color in the number line. And so although both of these are valid ways to write inequalities. Students do better when they write the variable at the start of the inequality. And just make sure you remember the meaning of the open circle and the closed circle when graphing. There's one more important skill that we need to learn here, and that's interpreting inequalities. This is kind of like literal equations that we did in the previous chapter, interpreting kind of what all of these letters mean for a particular scenario. So if I have A students in band and B students in choir, and B is less than A, is the inequality below true? Assume there's at least one student in choir. Okay, I'm talking about people here. If this were just a generic inequality, if I didn't tell you what the values for A and B were, then you would have no way of knowing if this was a true statement. But because I know that A and B are both whole numbers, they're positive numbers, I do have a bit more information here to go on. So at least one student in the choir. So if there's one student in choir, then there has to be at least two people in band. So at the very smallest, my numerator here is 1 plus 2. My denominator has to be 2. So at the very smallest, my first value would be 3/2. This is a number bigger than 1. We have a value bigger than 1 over here. Okay. Now, looking at the other half of the inequality, A over A plus B. Well, even in the worst case scenario where there's only one student, maybe two students in band, and 2 plus 1 students, okay? No matter what whole number this whole number is going to be bigger because there's at least one student in choir. So the bottom number, the denominator, is always going to be bigger than the top number. And what happens when you do a small number divided by a large number? You always get a number less than 1. So if we take a value that's bigger than 1 and a value that's less than 1, is it fair to say that the bigger than 1 number is less than the less than 1 number? No, this is a nonsense statement. This is not true. This is false. And therefore, we can say definitively that this inequality is false for the example for students in band and students in choir. One last thing before we go. There are different ways to express inequalities. And our textbook writes inequalities this way, and it also sometimes uses what they call set builder notation, which is something you're going to see more of when you get higher up in math. One thing that your textbook doesn't cover, but which you will also see higher up in math, is interval notation. So all of these that I've underlined here in red are different ways of expressing the same inequality. X is a value that's greater than 7. And so you can use curly brackets with set builder notation, or you can use smooth parentheses and square brackets to represent inequalities using interval notation. This is not something I'm planning to test you on, but the set builder notation does appear in your textbook, so I wanted to draw your attention to it here. I hope this helped.